everyone, this is Mrs. Heberling. In today's lesson, we will be reviewing previous learning about equations and inequalities and use this knowledge to explore how to graph and interpret linear inequalities. In this video, I'm going to show you the basics of graphing lines with Desmos.com. So once you navigate to this website, you want to click this large red button that says Start Graphing. If I want to graph an equation, all I have to do is type it into this first blue box here. So let's say I start with the equation y equals 2x plus 5. You can very easily just type that in using the buttons on your keyboard. If I want to add another equation, I can press this plus in the upper left-hand corner and click expression. And maybe this time I'll do something with a fraction. Y equals, if I want to type in a slope of 1/3, I can do 1 divided by, and instead of, there's no division symbol on your keyboard, you want to use the slash that's underneath the question mark, third, arrow over x minus 6, for example. And one last example I want to show you is an expression or an equation that is not in slope-intercept form. So I can type in an equation like 2x plus y equals -5, and typically in your graphing calculator that would need to be in y equals, but in our case we can type it in just as the way it is and it will still graph. The last thing I want to go over is how to turn these into inequalities. So let's say I want to turn y equals 2x plus 5 into y is less than 2x plus 5. I can put my cursor next to that equal sign and delete it, and all I need to do is press shift comma where that less than symbol is, and now you can see that it changed my line to a dashed line and all my shading is below. Let's say I wanted to make a greater than or equal sign in this second equation. I would do the greater than symbol, so shift period button, and then all I have to do is type an equal next to it. So I typed greater than equal and it changed it into this one greater than or equal symbol, and you can see now that's a solid line shaded above. The last thing is this can get a little overwhelming. If you want to turn off any of these equations and inequalities, all you have to do is click the colored circle on the left-hand side of the screen. So if I want the blue one to go away, you can click that to hide it. If you want the green one to go away, you can click that to hide it. In Chapter 5, we focused on solving linear equations and modeling them on a coordinate plane. In Chapter 6, we explored simple and compound inequalities and modeled them on a number line. Today's lesson will marry these two topics as we explore linear inequalities. You will see linear inequalities written in slope-intercept form, or y equals mx plus b, just like a linear equation. You can still identify a slope and a y-intercept, which you can still use to plot points on the graph. However, there is one very big difference to be aware of. Instead of an equal sign, you will see an inequality symbol. Less than or equal, greater than or equal. When modeled on a coordinate plane, you can clearly see the impact that these symbols have on the graph. The graph of a linear inequality will not be a single solid line as we are used to seeing. Graphs of linear inequalities will have a solid or dashed line and will have shading that indicates whether the solutions are represented by the points above the line or below the line. This presentation is a quick review of how to identify solutions and non-solutions. As a reminder, a solution is an ordered pair that makes an equation true, while a non-solution produces a result that is false. We have reviewed this information algebraically, where you can substitute an ordered pair into an equation or inequality and look at the final result to tell if it is a solution or non-solution. Now we will explore what it looks like graphically. When you graph a linear equation, solutions are the points found on the line, and non-solutions are not on the line. When you graph an inequality with a solid line, solutions are found on that solid line or in the shaded areas. Non-solutions are found in the non-shaded areas. When you graph an inequality with a dashed line, solutions are only found in the shaded area, and non-solutions are on the dashed line and in the non-shaded area. To recap, we learned that linear inequalities and linear equations both contain a slope and y-intercept. The difference is the symbol. Rather than an equal sign, the symbol will be less than, greater than, less than or equal to, or greater than or equal to. These symbols all dictate changes to the graph, like whether the line is solid or dashed and whether it is shaded above or below. Rather than solutions being on the line, solutions to linear inequalities are found on the line as well as in shaded areas.